Okay, so now -3 equals, we have this here. What do we do with this? How do we treat this? Do we do something with this exponent first, or do we deal with these numbers first?
I could be wrong. Don't you like? don't you distribute it?
Well,
No.
I'm gonna give you something. You can distribute.
You can.
When you have
the whole thing, or
when you have a coefficient on the outside, you can distribute.
don't you like multiply?
Or
both
do you
of
do?
those?
Don't you do like -3 squared and then check points?
No.
What do you think you do?
I think you take the -2 and you multiply by -3, and then like you divide the square.
What?
I think we have to apply the exponent first. What do you guys
I think you're thinking. I know what you're talking about.
Yeah.
Though, like if we multiply an x by an x, it's x squared. I think that's what you're thinking. Because if you're doing like a formula, like one of the questions on my midterm, which I actually got right, which is like not a brag or anything. That's like the only thing. But it was like
you have to study
the formula for area, and it was like you had to solve for radius.
right?
So like to get rid of the square, you do
Right, you switch
square
over.
You divide.
Oh, you're talking about,
Yeah,
okay,
that's what she
so that's kind of, let me just take it on the side for a minute and show you, okay. So here's an example of where you would use this exponent, like a squared, and then use a square root to get rid of it. I'm gonna show you a little side example to show you what you're talking about. It's a little different. So here's Pythagorean theorem. A squared plus b squared equals c squared, right? Now let's say you have a triangle.
Subtract b.
Well, first though, that's if we want to isolate the base. So like, let's say we've got a triangle, okay? And let's just say you know 2 sides of the triangle, but let's make it a right triangle, okay? So we know this side is 3, and we know this side is 2. And what does that mean we have to figure out? If I have this side of the triangle and this side of the triangle,
You have to figure out the missing side.
right? But which of these, A, B, or C, is the missing side on this figure? Do you know?
C.
Correct, because it's always the hypotenuse, which is always opposite of the right angle. Always. Hypotenuse is the longest part of the triangle, right? And it's always across from the right angle, always. So if you see a triangle, you see these on the SAT later on. So that means that we can start to plug this in. And honestly, to me, it doesn't make, you're still gonna get the right answer whether you put 2 or 3 here. So that's how I like to do it. And I do like that, and then I have c squared. And what do I have to do here?
Add them together. Okay, I have a question. How do you like know which one is A and which one's B?
It's the ones that they give you, and you can.
Oh wait, this isn't a good one. I have to add something to this. So yeah, because now we would only see that this would be
Because you have to,
9,
like-
10, 11, 12, 13 on this side.
No, but because like basically you could be like they don't really have like a thing. You just have to like find like the 2 numbers
So
that you have, and then you just be like, oh, A can be 3 and B can be 2.
Right.
Doesn't matter on order.
Okay.
I think.
Actually, let me think for one quick second. I want to give you, this one's not, now how does this work out with the C? Do we add this together?
Yeah.
We can't do it because this becomes 13, and if you radical a 13,
It's not gonna come
it becomes
out.
an imaginary number
I'm so
actually.
confused. I don't think it's gonna happen because I think what might have had to happen is that you just add them together and then you take the square root and you put square root.
That's right. So let me do different numbers. Hold on. Let's say we have, these numbers are not good because I'm coming up with them off the top of my head. Let's say we have, let's see. I'm going to do,
5 and 10.
no, I got a really good one for you. Let me just think though so I can do it right. Okay. We've got 2 triangles, right? Okay. And there's 2 triangles in here, okay? So when you see this, this is an SAT problem. What you do is you put another, that means there's another right angle there, right? So if we had, I think this would be, I have to look at about 18, 10, 3. But yeah, this is 18. And then if we have, this one I believe is 6, let me think, 6. Yeah, you want to do math too?
Okay.
This is 6. And this is, this one, okay, yeah, no, this is 6. And then I think you're given a triangle like this. It's got 2 in it. Sometimes they say draw them separate. This you can also use Pythagorean theorem for. A squared plus b squared equals c squared.
What would be our c squared?
Well, here's the deal. What we want to find out, first of all, we want to find out because we want to find out what this whole piece, if this is just 6, we want to find out what this whole piece is along the bottom, right? And we want to find out if this is just 10, what this whole piece is here. What you see in geometry is this is like dilated. This is like a bigger version of that triangle. If you start to see the number patterns, you could see 6 times 3 is 18. You might say to yourself, well, maybe times 3 here, maybe this is 30. You have to plug the numbers in. So if you do, you have to pick. So for 10, this is your, where's your hypotenuse here, right? So you could put 10 here. And if you wanted to, because we don't know that side either. So if you wanted to do, you could do, that's hypotenuse, you can make one of these 6 plus b squared. So you end up with 36 plus b squared equals 100, right? But, do you see it?
No, we just all.
So, but we have to do something here. Don't we have to put a little radical over this? Do you know? You guys don't know Pythagorean theorem.
We barely went over it. We like did. We went over
Guys, like, what are you doing?
like, what is going
Okay,
on?
I
so-
learned that like 2 months ago.
The second math started
And then you-
using letters, I lost all of
It's
them.
essentially, okay, pause this a minute. We'll come back to this. I'm going to show you that in a second. We're going to spend a whole, like, 15 minutes on Pythagorean theorem. First, let's finish with linear stuff and plugging in the variables, and then we'll talk about it. So here, what do we do first?
Well,
We have to apply which, the exponent or do these?
Oh, that.
Mm-hmm.
Don't you like distribute the negative 2 into the negative 3 and then multiply? Or oh, so you do negative 3 squared
Don't you
and
write it
then
out
times
again twice?
and then you solve. It was negative 3 squared. I
Don't use the
Well,
calculator.
is it 2 negatives become the positive because it's like you're multiplying, right?
Square just negative 3 times negative 3. Negative
That's right.
You
So-
positive then?
Yes. But then look, this bad apple spoils the whole bunch. So what you have to come up with is then you say this is what? Negative 18 minus 9, and g of negative 3 is equal to negative 18 minus 9. What is that? Think of your number line. You could make a little picture on your paper. If you get confused, you always have to include the
Or
origin
like
point.
calculators, obviously you just
I know you can, but I want you to understand it too. So you could do negative 18, now you want to subtract 9.
So go down.
Do you? What do you think it becomes? And then check it on the calculator. Yeah, you too! You know the answer. She's telling you. There's your calculator. Pick it up. Use your tool.
Don't use the calculator.
Wait, how do I turn this on?
She doesn't.
Oh, wait, there it is. Okay, never mind. I found it.
Okay.
Don't use the
Okay,
calculator.
Don't use it. Don't use it.
Oh, we're not allowed?
Well, on the regions you can, but what do you think this is? Count back.
I thought it was.
Just do the math in your head.
I did it right. I said negative 27 and I just checked it.
There we
Good.
go.
Okay. So negative 27.
Ooh, that's
So
it.
what this essentially starts to mean, and if you don't have the calculator, you gotta think on the
It-
timeline.
You should always practice when you do math, not to use the
Mental.
Yeah.
I
calculator.
agree, honestly. I
What
agree.
happens
So
is
then don't you do
when
something with it?
I just don't trust myself.
And then it becomes
that's
Yeah.
fine.
27.
That's okay because
Yeah.
No, honey, that's
you're not learning
But
this
good.
just for the region. When you go to
Yeah.
college
this is it.
and
So what
when you
this
go to
means-
grad school,
What
all the
this
tests,
means-
well at least in college
this is your
classes, if your
X on the
professor
graph,
is good,
This is your Y.
they gotta see how you do the math.
Yeah.
They don't want the
I'm
numbers.
gonna show you a
Just-
really easy
they don't-
version of
They don't
this.
know. They don't want to do the math either. They want to
Because
see
on
the
the
process
graph,
how you
your
write
point
it
is
out.
this. If you
So
want
you're
to
gonna get
graph
full
it,
credit if you have it right,
Yeah.
or if you get it just
they
like
give you.
calculate the
That's
answer.
it.
Okay, wait.
If you get it
so
wrong, you
you
get no
see
the
credit.
G is
And
like
if
the
you
X,
get it right, they're gonna
and
think you
then,
cheated.
like, it's just
Because you don't have any work, and then
Yeah.
by the time you get it, it's like I
Now
don't
let me
remember.
show you a
Yeah.
really
So,
better example of this.
And
So
also
let's
on
summarize that.
graduate
We'll come back to Pythagorean theorem,
exams,
because
like
that's a whole
any
lesson.
kind of grad level exam, you don't have time to use a calculator. They
Yeah.
don't. They make sure you don't have
We'll
time to
clean
use
it.
it, even though it's allowed, but you
Yeah.
just
This.
don't have time.
It's
So
only
This
like
is
for like
like
specific.
Hmm?
It's like only it should be used for like specific.
yeah, only if you get stuck,
Yeah.
like absolutely you need it, then
This looks so familiar to something, doesn't it?
MX plus B.
Right? Y equals mx plus b. This is slope. This is a linear equation. What does slope tell you? Slope tells
Right
you
over wrong.
what the line is doing on the graph. Right? y-intercept, actually. And the reason this gets confusing is because a lot of people say, okay, this is y, how is this the y-intercept? But it is, and then you could graph whatever the number value of this becomes. You could say x equals such and such. We'll just say mx plus b for now.
One way to avoid the confusion, just don't forget the y, use the fx instead of y.
Right on, yes. Because this is telling you that this is a function of x. So what you have is an input, and it's going to give you an output, right? So if I made this, if I want to make this problem into this now, this is something like they might give you like this. Make it really simple. We'll just make it f of x equals 2x plus 3. Now, if I tell you, if we made a table, we could let x equal 1, 2, and 3, just to see a pattern now. So I'm going to make an xy table, and I'm going to say x is 1, 2, and 3. And I want to find my y value. So I rewrite the function, putting in each of these test values for x. That's my input. I want to see what my output value is.
In my math class, we just like plug it in using alpha y equals.
Ooh.
Alpha y equals. It's like the buttons on the calculator.
You press.
See, this is why they don't know how to pass the test. They just plug it in. Go ahead.
Well, they told us that's how my teacher told us.
Yeah, but then you're not going to know how to do it in your head. So let me show you my way, the way that everybody else used to learn. So let's just do this real quick, because this is easy numbers to do in your head. We have to plug in the 1, so 2 times 1 is 2 plus 3 is 5. So f of 1 is equal to 5. We can plug it in similarly for 2, so quick, right? We'll do 2 plus 3, and then you end up with what? F of 2 is equal to 2 times 2 is 4.
7.
Excellent. So f of 2 is equal to 7. And then, if you want to test if a function is linear, kind of like in rise and run, you need to test at least 3 points, because you want to test for a rate of change, which we're going to do on the table in a second. We're going to enter in our y values, and we're going to look at how the rate of change is consistent, which tells you that a function is linear. So you've got f of 3 equals 2 times 3 plus 3 is 6 plus 3 is 9. So really easy mental math just to see how you work this problem. Then you can put in your values. For f of 1 is 5, exactly. Now, you can see that between each of these numbers is a plus 2 or minus 2, depending on how you look at it. If you're going 2, that's the difference in between here, right?
Can you just like take it and be like, oh, you put like odd numbers for it? Like,
Oh, that's so easy.
like
You
odd
could.
numbers?
Right,
Like,
sometimes
so
they'll tell you.
Be like, oh, like 5, skip 6, 7, skip 8, 9. Can you do that?
You could discern a pattern from this. Once you know that the rate of change is consistently 2, you know it's linear, which means it's going to be a straight line on the graph, like a linear line.
I don't know parabolas.
So basically,
Parabolas are quadratic. That's a whole
So
nother type
basically,
of
it
function.
would be like 4,
I'll show you
11,
that too.
and like if it was the graph's going to continue,
Mm-hmm.
and then you take the y and like you take the x and the y, and then you put like 1, 5 on the graph and you plot it.
That's right, because these become ordered pairs, exactly, in the form of x, y. And you can plot it on the graph. This would be your ordered pairs. And in geometry, sometimes a lot of the time they make it like this would be point A, B, and C, right? So you can order this, and what you'll find is they will always be a straight line. Let me erase this a minute.
Wait, that's actually makes so much sense.
Do you want to take a picture of it before I erase it, anybody?
No, I got it.
I can show you the notes for this too.
I think you did this before. I just forgot.
It's such a key. Well, another thing I meant to keep remembering me parabolas. I just erased it. Hold on, I'm gonna work this in a minute. So what I wanted to show you too is that's weird. I think you're saying parabolas. What was I gonna just show you? Linear equations.
Is that?
Oh yes, here's a trick. Now, when you're dealing with math, you sometimes see order of operations, which is PEMDAS, right? Now, this is talking about operations,
Equal sign,
right?
equal.
But oftentimes, they don't specifically say, you would say, okay, here's the not just operations, here's the methods.
I love him.
Right, this is easy to follow.
Wait, can we like do one?
Yeah, we will in a minute, we'll do one. We could do and quadratics, everything. But what I want to point out is this is about operations. And we're going to talk more about that. But not only is math about operations, it's about methods and methodology. So sometimes you see numbers, thanks Kai, sometimes you see numbers expressed as decimals, and sometimes you see numbers expressed as fractions. This is a really important way that you can manipulate numbers. And I will show you examples where you do not want to be using a decimal. It's better to use a fraction because the decimal becomes run by so many numbers. You know what I mean? When you have a lot of numbers, you don't want to, so we use a fraction in that case.
I don't like fractions.
Well, fractions there's many ways to work with fractions, but the trick I want to show you is this, for the purposes of your math. A lot of the time you'll see like 1/2 as a coefficient instead of 0.5. And that confuses kids as to how they need to multiply it. So here's your trick. I call it the rule of thumb. This is easy as pie. You need to know how to convert between decimals, fractions, and percent. Yes.
I remember this. You wrote it on the map.
Right. I did write it on the map.
Can I say one of them?
Yes, you can say one of
How
them.
you make a fraction into a decimal is you multiply the numerator by the denominator. Or is it the denominator by the numerator?
Denominator by the numerator.
Well, I divide.
It would be 2.
I thought it was divide top by bottom.
Well, no.
Wait.
Right, yes, it is divide top by bottom. I always say the guy at the bottom is trying to get to the
it's not
top.
that. It's
Like in business, the guy who's at the bottom, he's trying to get to the top. This is always your denominator down, right? And you divide this. Now wait a second, think about this numbers now. If you divide 2 by 1, what do you get? You get 2, and that is not 1/2.
Yes.
So this is your rule of thumb. Anytime you have a more complex fraction, you write this little thing down, and you make sure you're manipulating your fractions the proper way.
Okay.
So once you divide it, you know this is 0.5, right? And then you have to multiply this, that's right, to get 50%.
That's what
So this is fractions. I'm going to ask you girls a
How do you
question
make a
now.
how do you make a percentage into a decimal?
Good question. So in order to make any percentage into a decimal,
Just
you
divide
have to divide, right, by 100. And then you get your 0.5. And the reason I say this is the rule of thumb is because if you're working with any more complex mixed fraction, whatever it is, if you know how to manipulate these numbers, you can check yourself. Sometimes this helps me, and I'll show you it in application as we work through the problems, but this is a skill. The one thing a lot of kids don't know is how do you make the decimal back into a fraction? Do you guys know how to do that?
Don't you? Yeah, no.
The way I
I was gonna say you moved the decimal point over, but no.
No. Well,
Yeah.
the way you're going to do it is, okay, if you have 0.5, just ignore the 0.5 for a minute. I'm going to write it, but pretend this is 5 over 10. Okay, what if I had 0.50? Then you're going to put it over one more significant figure. You're going to put it over 0.50 over 100. So you can see, you cancel them right out. You end up with the same thing.
Yeah.
Okay, so you'd reduce this. You'd say 5 goes into 5 one time, 5 goes into 10 two times. You end up with 1/2. But you see it? But what if you end up with like?
What if it's like a weird fraction?
Well, yeah. If you have like, for example, like if you don't have an like if you have points. Hold on, let me think. I want to do which numbers? I want to do like 0.3. We can do 36. Yeah, let's do that. 0.36. Let's say you had 36% or 0.36. What do you set it over? 10 or 100?
100.
Exactly, because you can see that you're always going to do one more. So once you do that, usually you want to start to reduce this fraction, right? You okay with this?
No, you're not. Like, and she wants her dog.
You're our youngest student. Okay.
Algebra 1.
So what's half of 36? If you can't
I know, wait, that's
see it as 36. 36. This is half of that's 15, half of that's 30, and it is 18.
Yeah, I was thinking of 6 times 6.
Do you see how I separated the 10s and the 1s though?
Yeah.
And you can see them in half that way too. So that's right. So what's half of 100? You put it over 50. Can you reduce this any further? Can you put it in half again? What does it become?
9
tell me what that decimal becomes. Well, I know it's going to become.
Wait, what is that? What do you want?
36 divided by 100.
She said divided on purpose.
Yeah.
0.36.
You're right. Exactly. And then what about, okay, what if you do 18 divided by 50? 18 divided by 50.
Oh, 18 divided by 50 is 0.36.
Oh, interesting. Wait a minute. These numbers are all 0.36? Even 18 over 50? Yeah, do 9 over 25.
0.36.
0.36? Okay. 0.36. Don't you find that kind of funny now? What does this tell you? Something you probably didn't know about fractions.
How we get
all
all things so the same doesn't keep
Is that wild or what? So this is, let's do another Regents problem now that we've discussed the methods.
just not getting it.
Okay?
I know, but
Give her a food pouch. You want to give her a food pouch? I know, but she's going to just, there you go, Anna. Listen, sit on under.
Okay, you need to know.
We have a young student. Okay, now I want to do another problem with you.
Not me. There you go, you can do it.
Let me see what's next.
Right.
I think I'm going to turn this off because it's hot.
It's on?
More.
Yeah, it's only on 17 now.
It's okay. Next problem we're going to look at.
Ooh.
What is a rational number? Let's see, which expression was
A
a
rational
rational
number?
number?
It's positive numbers only, I think. Right?
Mhm.
Yeah. Irrational numbers are positive and negatives.
Here's a perfect problem that they give you. 3 over 5 x. Jay, look what he said. Pay attention.
You just get
4 over 3
on the camera.
equals 1.04. We're going to need to use the calculator for this. So this is a 0.
Yeah.
Okay, ready?
You
This is the same
put
thing
that
that just
into the
happened.
group X.
Okay.
Distribute.
Okay.
3 over 5x.
But then what?
You
Make them
add.
into decimals like
It's
I
either
told
you
you.
add or you cross multiply.
Conjure, but let me sort you.
It's 1.333 repeating.
So that's repeated.
Half. 1.3 half.
It's a big decimal, so we have to keep it as a fraction. So what is 3 over 5 times 4 over 3? Do you know how to do it down here? Let me show you. So 3 over 5. 3 over 5 times 4 over 3 is 4/5. So you end up with
Oh, that's gonna be a little thing.
yeah, equals 1.04. Because we don't distribute after the equal, right?
Wait, don't you?
Mhm.
Oh,
Well, now what you have to do is you have to
get rid of.
subtract this from here, right?
Yeah.
Right, so subtract 4/5, cancels that out, subtract 4/5. What does that become? 1.04 minus 4/5. You can make the 4/5 into a decimal if it suits you better.
Teach me how to plug it in.
Well, you don't plug it in, you go like this. So the way I do it is I do 4 divided by 5 like that,
Oh, you just do that.
and it's 0.8. So watch, I now made this 0.8. So now I'm saying subtract. Alana, JD, are you paying attention?
No, the babies.
Zaza. You remember CP?
You
No.
went.
No. Okay, so we can actually make this fraction 0.8. So now it's easier. Do you see it? How much easier it becomes? Because now you're dealing with the same language. You're dealing with 2 decimals instead of mixed numbers, mixed fraction, mixed decimal. You've got them, they're speaking the same language, so it becomes very easy to say 1.04 minus 0.8 is 0.24. So this equals 0.24. And on this side, you bring down your 3/5 x is equal to 0.24. What do you do next? This is where you isolate, right?
Divide.
Mm-hmm. Because we're isolating x.
3 over 5.
That's right.
So that cancels out. And then 0.24 divided by 3 over 5. I don't know what that'll be.
Okay, so this is why they make you use a calculator, because the mental
Well,
minute
you can't really,
freeze it.
it's hard to do with decimals, because like, you know what I mean? It's just
That's why it's actually 0.4. This is why I'm going to show you this again and again. This is why I showed you the trick. It's much easier to convert the 4/5 into 0.8 for me, and I think that's the case for a lot of people. But now what happens when you get this answer? You have to plug it back in to make sure it works. Exactly.
That's so easy to do.
So let's check it. So we plug in 3, and I know it's right, so we would plug it back in, exactly. Let's do another one.
let you go and get the chance.
This is your first table. This is number 1. This is choice 1. This is choice 2. I'm going to ask you a question. And wait a second, it's choice 3. This is choice 2. Okay. And then we've got choice 4.
Do we turn off the heat pump?
I did, is that bad? Oh, it's still hot.
Really? Oh.
Yeah, do you want it on still? I didn't
Because-
switch it off downstairs.
Because not cold. True.
Sure, okay. Oh, I thought it was
That was cool.
if you guys want it back on. You're cold?
I'm like, that's a good temperature.
Okay.
Hi.
I know.
Oh my god, we learned this on this off.
Which one of these, 1, 2, 3, or 4, does not represent a function?
I don't really know. All I remember is like either 1 or 4. I think it's 2. Is it 2?
I feel like it's 1 or 4.
Well, if this is your, okay, so here's the thing with this. This is an input, this is like your x. This is like your x, and this is your output. This is also called another thing, another AKA. This is called domain
And range.
and range, right? So, what happens, can you have in a function, could there be more than one value for x producing 2 values here? What do you think?
No.
No.
But what can I teach you? Like, can I tell you?
You
what
wanna
I
teach
did?
it?
No, I want to use that.
Okay.
So in Mr. Slaw's class, he did this really good example. I don't even remember with Mr. Slaw, but it was like, okay, if those are the inputs, I don't remember exactly. I'm trying to like go off of memory. I could be wrong. It doesn't make
That's
sense.
how we work it
But
out.
if it was like, oh, these are like students, you can't go to one classroom at the same time. Different
Exactly, I
students.
like
Go to,
that.
like different, different
Right,
students
like,
could go
if
to
these
the
are
same
people, they
classroom.
can't be in the same place,
Yeah,
2
but
places
like
at
you can't.
once.
Yeah,
I love
I
that.
don't remember if it was vice versa.
It's actually pretty good. Alana, if these are people, you can't be in 2 places at once.
Yeah.
Okay? So from that being said, this is not a function, so that's out. 4 is out.
I think it's 2. I could be wrong though. Because I will. It's not a linear.
This one could be, well, the thing is, for every x and y value point along it, it's not repeating, is it?
It's either 3 or 2.
Well, the question was to find the one that's not a function.
Wait, if it's like
I think one's a
repeating.
function.
No wait. So if it's like repeating, do you like go like if it's like on the same way? Like the same like distance. Wait.
No, you gotta try to say, I'm listening, you explain.
Okay, so like you see how like you have like the 2 like ones that are like really far away from each other but like on the same line? Would that be like not?
It could be, no, it would be a function because they don't have,
Which
for
one
every
would
x
have to
and
be like-
y, remember we were saying like each point's like an x and y?
Yeah.
You're not gonna put in, well actually, could the same x produce the same y? Could it?
That's what I just said.
Right, no. So I'm gonna go with 4. What's your final answer?
I think it's 1. Oh no, sorry, 2. Wait, is it
This
2?
looks, well, you can look here.
No,
like,
I think 1's a function.
And the other thing is, like, you see how these are decimals, and you might not readily see that, but if you even look at the pattern here, 2, 4, 4, 6, you see a little bit of a
Yeah, but I
pattern.
don't get, because 3 is like y equals mx plus b, but would that be different because it's like in the square root? Like, is that why it's not a function? Because I was looking at it and it's like,
Only
oh,
one of these is not a function.
I don't know if it's 3 or not, because I don't know if it like counts because of the square root of. So
Which one doesn't, which relation does not represent a function? Well, we know, we don't even need another rate chain on that. If there's an x and y values that are all separate like this, and you don't want to see them repeat, 1 to be 6 and you want 4, like they both can't be 6 in other words. You get what I'm saying?
Yeah, it's not repeating.
Right, because you're plugging it into a specific formula for that function. So for example, when we had the f of x equals 2x plus 3, we're not going to get, if we put 1, 2, 3, 4, 5, we're not going to get the same number repeating on this side for y, where it's not a function. So, could this be a function?
Yeah. Right.
I don't think so.
Wait, it's not.
Because these are your x's. Would those x's give 2 different y values if I plug? Right. So this is when it's not the function. This doesn't overlap itself. Every x here gives it way to its own y.
Yeah.
Right? This one's a little trickier to see actually. I'm looking at it and I'm like, what is going on with this one, right? We would have to know a little bit of manipulation. This could totally throw you off.
So,
How can we know this is a function?
or you can't, I'm sorry, I'm a little off.
It's okay.
I know you're
I'll show you a check.
I'm so confused. Is it, so wait, you can't repeat x's or you can't repeat y's?
You cannot repeat y's. Your x value will not yield more than one y value
Yeah, because if you
in a
have
function.
one more than one,
Your
then
x
when
value.
if you were
Right, like there's 2 students. Right. Like you just said, 2 students can't be in the same. So let me show you a little strategy. Show me what her baking done.
Where's your bacon?
Let, do you know what an arbitrary value is? It's a pie in the sky made up number. Sometimes you can pick one, like 1 or 2, and we're gonna test out a problem. Now let's pretend let x equal 1 here in this particular thing. First of all, we can see it is y, so we know that it's a line, so it's probably a function right off the bat, right?
Well, it looks like it's an m. It's supposed to be.
What if I got, now underneath here, I'm gonna let x be 1, so now I have 2 under here. So if you plug this, oh, I have the calculator. So if you say 3, and then we wanna do, where the heck is my radical? I have to do this
A
little.
lot of this other the instant.
You're not gonna know this calculator because it's way older than yours, but I have to press that. So if we do 3, could you do anything with this too, radical 2?
What do you mean?
Could you do anything with radical 2?
I don't know what that is.
It means like, okay, so if you have radical 4, what does that equal?
What do you mean by computer?
Radical 4, do you guys know what to do with this? This is very important too.
Don't you square root it and then it equals 2?
Does it have
Okay, exactly, it's just like a square root,
Yeah.
right?
So like
you do,
2, what's
exactly. What is radical 9?
3.
Right. So, can you do, so you can start to test numbers in the x value. We're gonna look at that strategy a lot. We're not like thrilled with this exams problems yet, but there's a couple good ones. So let's do like at least 5 more, okay? And we'll do it a little faster before Zelly gets impatient with us.
It's starting to happen.
I know, it's starting to happen, alright? She's like, I'm not having it. But you're already a good student, though.
I gotta eat food. I'm like hungry.
Okay, how
No,
about?
no, but like this this doesn't happen.
Perfect.
This is like
Okay.
chips.
Well, here's a quadrant. We should cover the
Yes, sir.
quadratics.
Oh, shit, stop.
Also me in 6th grade.
This is all quadratic, the zeros of the equation. I'm going to stick with functions before we get into quadratics. I'm going to try to find a similar. So here, okay, so exactly, this is composition. You've got a parent function, f of x, and you have to find the function g of x. Have you guys done that yet?
Wait, can you repeat that? I'm sorry.
Do you ever see parent function f of x, and then you have to find the g of x? No?
I've never.
I didn't learn.
What about,
Actually,
No,
I don't know.
I remember,
I
I,
can think of
I remember hearing it a lot. I remember G of X.
so I'm going to teach you composition and quadratics, but right now we'll stick to linear. So here's a linear problem. I'm going to read it to you, and I'm not writing the whole sentence, so pay attention. So Mark bought a new laptop for $12.50. Your dad's name.
For
$12.50.
Like an equation on word problems?
Kinda. I'm going to ask you which function determines the
My dad would
determine.
buy a computer for that much. You'd probably find it like on Amazon for like half the price.
Well, that's
And,
how
like,
I
broken.
got mine. I ordered mine like that too. It's a good computer for that price, right? And now, Mark's tracking the value of his computer, which is probably going to go down. That's called depreciation. Cars do this. So he's tracking his value over 3 years, okay? So it actually says years after purchase. This is what they give you. Okay, no dog then. No dog players. Okay, I'm going to give you some dog. Where's your pink? See if she'll eat her octopus. You want an octopus? Oh, it has a hair on the tongue. Everywhere. Okay. Okay. Okay, so this is years after purchase and this is value in dollars.
Oh, that's weird.
Okay.
So old now.
You ready? 1, 2, 3. Okay, do it, babies. 1,806.40.
I'm paying attention.
You know,
They're
they're
making me laugh.
You probably did. Now, being that they're giving you this, girls, you have to know something important.
Okay.
This is X and this is Y, don't forget. You will never see an ordered pair go in the order YX, ever. It
Because
is
then it's
always
gonna be
XY, unless you're doing trend later on and you're looking at,
That's what I'm talking about.
yeah, when you're looking at, like, if you're looking at cotangent, then you're gonna see X over Y. I mean, if you're looking at tangent, you're gonna see Y over X.
I know you're not supposed to have Y, comma X, but I don't know the reason why. Because like,
It just doesn't make
technically,
sense.
no, because technically you could still be able to put it on the graph. But
Well, I'm gonna tell you why.
why.
This is a really good question. So these are some of the things that always have confused me. So the reason why is because X is independent. You know how I remember
Oh,
that?
I never depend on the Y. Yeah.
Exactly. Like, for example, if you were doing a time versus distance graph, where does time go? Along the X or the Y?
X.
Yeah, because time goes on no matter what, right? And maybe in time something's happening that is influencing the dependent variable, the Y.
So it's
So-
gonna be years after purchase X and then value
That's right.
dollars Y.
Yes, absolutely. So now if you wanted to graph this, you could, couldn't you? Of course, the
Yes.
scale would be pretty big because
And
your
then you would, like,
X's are,
Or you could just like break it and count it by like
or
100.
you could even be like, shh, and then you see the pattern emerge a little bit more.
Yeah. And then you can count by tens.
That's right. But in this case, they're not asking you to do that. What they're asking now is they're saying which function can be used to determine the value of the laptop for X years after the purchase. So they give you 4 choices. Choice 1 is f of x equals 1,000 times 1.2x. That's your first choice. I'm gonna help you.
I'm a little confused.
Don't worry. Let's look at all the choices first, okay? Because some of these might not even be the choice, and that could be why they're confusing. So let's see all the choices. Always look at all of the choices, even if you think you know the answer. Make sure that you're looking at all the choices.
I don't know what that one.
There's a couple of things actually, funny enough. They've got all exponential things going on here, which I find very odd. But it looks like it may be exponentially depreciating. Okay, 2, I'm gonna plug in numbers. F of x equals 1,000 times 0.8 to the x. Can you make out my 8? And then we've got 2, this is 30. And then this is 4. Is f of x. Does she like it?
Wait, 2 and 3 are the same
So
thing?
I think she likes cut.
2 and 3 are the same thing? They're both 8.
What is it?
0.8.
Yes, they are.
That's
But-
weird.
Yeah, they're all doing 0.8.
No, I mean like they're like the same exact thing. 2 and 3 are the same exact
They're
thing.
different.
No, 2 and 3, the thingy.
Oh.
They're the same exact thing.
Oh, 1.2.
That's fine.
Good call. Okay, 1.2.
Wait, but then those 2 are the same thing.
No, that is the same. This is
No, she's
No,
not
1 and 2 are the same thing.
1250. This is 1250.
There we go.
Okay. Okay.
I think there was a little there.
Okay, well, you're paying attention, aren't you? Okay.
I always pay attention, but I never say anything until someone else says something. Like if the teacher makes a mistake, I'll just wait for someone else to say
Just say it.
it. Unless I see like
which one is which.
What can you do here? It's actually pretty.
You look at where the number placements are, and then you figure out why they're there. And what mistake did the person make on 3 of them?
Yeah, well, hold on. It tells the function can be used to determine the value of the laptop for X years after the purchase. Okay. We want to know X years. This is years. This is X. How many year value? What's the value in dollars? So if I plug in 1 for X to any of these functions, the right one's going to tell me 1,000. If I plug in 2 for X to any of these functions, the right one's going to show me 800. If I plug in 3 to any of these, the right one's going to show me 650. Now you don't got to plug them all in, but you got to pick a number to stick with. So whichever one you do, you got to do in all of them. So I want to pick. What you 2?
Wait, so I have one in here. So it's just plugging in. FFX, you just plug in something from the table.
That's right.
Not
something from the table. X.
Okay.
Why is that?
Okay, so you have your X. Okay.
Her eyes are so big.
And then you have FFX. Oh wait, so I was so confused because I didn't see that. I can't see the board that well. Like I'm squinting. And it's like that.
What's your prescription? I don't know. Let's see. Again.
I'm gonna check for my
Oh,
answer. You guys, this is a time test, so we have to always. Okay, so I'm gonna put it.
Yeah. Years.
I already know right off the bat.
No, she said it's a time.
It is Regents' is time test.
Yeah.
Yeah.
Ew.
You know how in midterms you have a certain amount of hours to finish the test?
You had hours?
Yeah. You have to
I had 40 minutes to do my midterm.
We have 2 hours.
Do you hear this? Do you hear this?
I got 2 hours to do my midterm.
And they get off from school.
And then I get off from school.
Okay, you ready?
40 minutes.
You ready to pay attention? Okay.
I'm in.
When I plug into here, the number I get when I plug into here is not 800. It is 1400, and therefore that is wrong. It is wrong. I'm gonna plug into here. 1250. My mama's here is all times 2, and then we're gonna plug in 2 for X. Oh, that's 1800. Too big.
Haha.
Now, right off the bat, do we have to plug it all in? I would suggest you roast it. Sometimes you can look and eliminate. Like, for example, this looks like it's going to be the right answer. Do you know why?
Because
It's 0.8 and 1,000, and this is 800.
because
It can. I don't really. I think I have to solve it.
1,000 times 0.8 to the second. That's 640.
Wow.
That's when I plug in. So that could be it. And then we've got, the thing is 640 is here, and it plugs in too. What about this?
That one.
1250 times 0.8. Are you getting fussy there? She has a very short attention span, like babies do.
I couldn't tell.
This one's 800 when I plug it in. Now test